faster than the space-time fabric itself. By itself, it has the capacity to keep an eye on it, and as a result, it will gradually eliminate this idea of filling. I'm becoming increasingly uneasy. At this very moment, the night sky is rapidly undergoing transformation, and in the coming decades, perhaps even earlier, it could become entirely unrecognizable. Leading experts, including Neil deGrasse Tyson, have sounded the alarm, recognizing the changes that must be made, brought about by the shifting position of Polaris. The changes behind this phenomenon are unexpectedly surprising. Polaris, also referred to as the North Star, has been a stable element in the sky for millennia, serving as an essential point of reference for astronomers. However, this may soon be altered, modifying our perception of the heavens and the method by which we investigate the universe. Let's examine the repercussions of this change. For centuries, Polaris has been a guiding beacon for sailors and astronomers, remaining unwavering in the heavens. This constant presence has been essential for navigation. But this stability may soon be disturbed. In a document published by the Royal Astronomical Society in September 2023, alarms were raised regarding the future of this celestial marker. Polaris is about to enter a tumultuous phase, one where it might burst and completely vanish from view, forever altering the sky we know. Before taking into account the potential outcomes of this event, let's take a closer look at the features of the star as a whole. Polaris stands out due to its position near the celestial North Pole. Located directly above Earth's northernmost point, it appears almost motionless in the sky. It is part of the Ursa Minor constellation, which is often referred to as the Little Dipper. Polaris emits moderate brightness and is classified as a white and yellow supergiant star, significantly larger and brighter than our Sun. Polaris is not just a single star, it is part of a complex triple star system composed of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational interactions between these stars influence their orbits, actions, and changes in brightness or pulsation patterns. Despite this, the exact nature of these forces remains poorly understood. Polaris is located approximately 323 light-years away from Earth, meaning that the light we see today began its journey a long time ago. If Polaris were to explode, the effects would not be visible to us for over 300 years. It is even possible that Polaris has already exploded, but we haven't yet seen the results. Throughout history, the North Star has held profound cultural, navigational, and symbolic significance. Because of its unchanging position in the sky, it served as a vital guide for ancient sailors navigating vast seas and lands. Symbolically, Polaris has represented stability and direction, remaining constant in an ever-changing sky. Polaris has helped astronomers by serving as a crucial reference point in the study of stellar movements and variable stars. As a type of variable star, its periodic changes in brightness have provided critical insights into stellar characteristics and behavior. This trait has also been crucial for determining cosmic distances and calibrating scientific instruments, as its pulsations follow a predictable pattern. Its actions have historically been moderate and easy to forecast. However, Polaris has recently begun to show signs of departing from its usual conduct. Its pulsation cycle has become irregular, catching the attention of astronomers and prompting further investigation. Rather than following its usual rhythm, Polaris is beginning to behave erratically, dimming and raising concerns that the star may be nearing the end of its life cycle. This behavior follows established patterns in stars that are approaching their final stages. The gradual increase in the duration of Polaris pulsation, which was once steady, has been traced back to interactions within its star system. Over the previous year, there was an annual increase of approximately 4.5 seconds in its pulsation period. While this might appear insignificant, it holds considerable implications. Some astronomers propose that gravitational forces between the stars in the Polaris system could be driving these modifications, directly affecting its atmospheric conditions and pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between Polaris's behavior and that of Betelgeuse, a prominent star in the Orion constellation, are striking. Both stars have displayed complex changes in brightness, raising concerns about a potential catastrophic explosion. Stars nearing the end of their life cycles often exhibit such irregularities before their demise. NASA has voiced greater concern regarding Betelgeuse, but formal attention has yet to be fully directed toward Polaris. As a Cepheid variable star nearing the end of its life, it goes through several stages, including the red giant phase, which may eventually result in a massive explosion. Given the observed irregular pulsations in Polaris, scientists predict that it has entered the helium phase, a state of instability typical for giant stars near the end of life. These irregularities align with patterns seen in other stars as they near their end stages. However, solid evidence of an impending supernova remains uncertain. Astronomers continue to monitor these anomalies to better understand Polaris's fate. If Polaris were to undergo a supernova explosion, it would be an extraordinary event in the sky, potentially outshining the Moon and remaining visible for days, weeks, or even months. Its brilliance could significantly alter our view of key constellations like the Big Dipper or Ursa Major. Fortunately, Earth would likely remain safe whether Polaris explodes or not due to its immense distance. While the explosion of Polaris might not be as visually stunning as Betelgeuse's, it could still be visible to the naked eye for an extended period, outperforming nearby stars. This would undoubtedly draw the attention of observatories and astronomers, sparking widespread interest both in the academic community and among stargazers. On the other hand, the effect on Earth's environment or ecosystems would be minimal compared to a supernova occurring closer to our planet. Now, let's turn our attention to what will happen to Polaris itself. After a potential supernova explosion, it's crucial to understand that although massive stars generally end their lives in a supernova, this is unlikely for Polaris. When a massive star passes through a supernova, its core collapses, causing a violent shockwave that tears the star apart. However, Polaris is not massive enough to undergo such a violent event. Instead, after it exhausts its nuclear fuel, it will release its outer layers and transform into a white dwarf. As a result, there will not be a traditional supernova. Instead, it will mark a quieter ending, as Polaris develops into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium-mass star that has depleted its nuclear fuel. Despite its small size, roughly that of Earth, it will still contain the mass of the Sun. Once this transformation occurs, we will no longer observe Polaris as it currently exists. By comparing the potential explosion of Polaris to actual supernova events, we can acquire useful insights into star formation and their final fates. For example, supernova. Understanding the implications of a potential Polaris explosion also requires examining the broader impact on observational astronomy. Polaris has long served as a cornerstone in celestial navigation and astronomical calibration. Its reliability has made it an invaluable tool in aligning telescopes, guiding spacecraft, and determining latitude and direction. The loss or transformation of Polaris would require astronomers to shift to alternative reference points, a transition that may affect scientific operations worldwide. While there are other bright stars near the celestial north, none currently match Polaris in terms of positional stability and brightness. Beyond the technical and navigational implications, the cultural and historical significance of Polaris cannot be overlooked. It has been a symbol of guidance, hope, and consistency in literature, mythology, and exploration. For countless generations, Polaris has inspired poets, mariners, and stargazers alike. Its disappearance, or significant transformation, would mark the end of an era and the beginning of a new chapter in our relationship with the night sky. The astronomical community is now keeping a close eye on Polaris. Observatories around the world are collecting data on its brightness, spectrum, and pulsation patterns. Space-based observatories, such as the Hubble Space Telescope and the James Webb Space Telescope, may also be enlisted to provide more precise measurements that ground-based telescopes cannot achieve due to atmospheric interference. The data collected will help researchers refine their models of stellar evolution, particularly for Cepheid variable stars like Polaris. Cepheids are vital to the cosmic distance ladder, a tool used to measure distances to faraway galaxies. Any changes in our understanding of these stars could ripple through cosmology, affecting estimates of the universe's size, age, and rate of expansion. Meanwhile, astronomers and physicists continue to debate the possible outcomes for Polaris. Will it fade quietly into a white dwarf, or could it still surprise us with a brilliant end? Will its brightness fluctuate unpredictably, creating new challenges for observation? Or might it regain stability and continue to shine as a reliable beacon for centuries to come? Only time will tell. Regardless of its fate, Polaris serves as a reminder of the dynamic and ever-changing nature of the cosmos. What seems constant in the heavens may, in fact, be evolving slowly, and sometimes rapidly, beyond our immediate perception. The universe is alive with motion, transformation, and mystery. Polaris, once the fixed point in our skies, may soon become one of the most fascinating case studies in stellar evolution and cosmic change. As we look up at the North Star tonight, we might be witnessing the final chapters of a celestial giant that has quietly shaped our understanding of the universe for generations. And in its light, however steady or flickering, we're reminded that even the brightest stars are not eternal, but part of a vast cycle of birth, change, and eventual transformation that governs all things in the cosmos. A crucial field of study includes the stars' pulsational variability approaching the end of their life cycles. Through comparison of Polaris to other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms that underlie star explosions. The creation in stars' pulsations, nearing the end of their life, may indicate instability inside or an imminent catastrophic event, providing useful hints regarding the procedures that, despite leading to the explosions of supernovae, are not yet fully understood. Detailed observations and ongoing research are necessary. Experts in the field are still perplexed by the behavior irregularities of Polaris. Understanding the causes behind these anomalies is vital for advancing our comprehension of stellar evolution. Investigating the underlying factors for the erratic pulsations of Polaris requires collaboration across multiple scientific disciplines, as well as the growth of cutting-edge models and empirical techniques. The potential loss of Polaris as a celestial reference point raises fundamental astronomical questions. Research using ground-based telescopes and measurements of distances between stars would require calibration, which could influence the precision of cosmic measurements. The disappearance of Polaris would also affect navigation systems and cultural practices that rely on celestial markers. This emphasizes the importance of such an occasion. The mysterious behavior of Polaris highlights the pressing need for further focused studies. Research must address the complexities surrounding its erratic pulsations and provide meaningful answers to determine the future of the star. The disappearance of Polaris would have major implications for various fields of study, including one of the most important cultural practices. Consequences include the requirement to recalibrate astronomical tools and techniques because Polaris has long been a reliable reference point for measuring distances across the cosmos. Its loss would disrupt current models of the universe that have relied on the star's predictable behavior for centuries to assist in tracing the cosmos. Without it, other methods of measurement would need to be developed, which may necessitate years of research and adjustment. Moreover, Polaris has always played an important part in navigation, especially for sailors and travelers. Its constant position in the sky has helped guide travelers across vast oceans and unfamiliar lands. If Polaris were to disappear, the disappearance would result in problems for current navigation systems that still rely on celestial bodies for orientation. This may be particularly difficult in remote locations where electronic navigation aids might not be as effective or accessible. In addition to practical concerns, the cultural significance of Polaris cannot be overlooked. For many ancient civilizations, the North Star symbolized constancy and direction, offering a sense of stability in an otherwise chaotic world. Its probable disappearance would have profound psychological and emotional repercussions for various communities, particularly those who have long associated the star with guidance and hope. Even today, many cultures continue to interpret Polaris as a sign of steadfastness in the face of concerns about the possibility of losing it. Additionally, Polaris emphasizes the dynamic and ever-changing nature of the universe. Stars like Polaris experience a variety of stages over the course of their lives, and their eventual death is just a part of the cosmic natural cycle. While the thought of losing such an important and dependable star might seem unsettling, it also serves as a reminder of the vast and complex processes occurring in the universe beyond our comprehension. Just as new stars emerge and older ones fade away, we, too, are always changing and developing as we go along. To study the stars and their behavior, astronomers will likely benefit from even more information about the stars' life cycles and the forces that govern their existence. This knowledge could eventually assist scientists in comprehending the broader processes that shape the formation, evolution, and death of stars. By studying how stars behave as they near the end of their lives, such as with Polaris, we can learn more about the unsolved issues of stellar evolution and the ways in which the universe itself is undergoing constant change. Despite the uncertainty regarding the outcome of Polaris, one thing is certain: it has been an extremely useful resource for astronomers and cultural customs. Whether or not it ultimately transforms into a white dwarf or goes through some other unexpected phase, its eventual disappearance is certain. It will mark the end of an era in our comprehension of the universe. However, as with other celestial events we've seen, new stars and discoveries will continue to appear, providing humanity with fresh insights into the nature of a universe. While the changes happening with Polaris may be alarming, they also provide a one-of-a-kind opportunity for scientists and researchers to explore stellar life cycles and the forces of the universe that shape them. The future of Polaris is yet to be determined, but the journey to understand its eventual fate is an exciting one, offering potential breakthroughs in our understanding of the forces that control the universe. As we continue to monitor Polaris and its shifting behavior, astronomers are trying to figure out how this star's change may have an impact on our broader understanding of the universe. The possibility of losing a steady celestial landmark forces us to confront how fragile the stellar models we currently have are and how cosmic measurements are made. Since Polaris has served as a key point for telescopic instrument calibration, its eventual disappearance or alteration could necessitate the creation of novel methods for measuring distances in space. Additionally, Polaris's gradual departure from its consistent function would push the scientific community to investigate in depth the mechanisms that underlie the behavior of variable stars. The comprehension of variations seen in stars like Polaris and the conditions of their final stages might change how we perceive the star's life cycle. These studies could extend beyond the Polaris system, influencing our research into other variable stars and their capacity to develop into phenomena like supernovae, neutron stars, or white dwarfs. Another fascinating aspect of the situation is the ripple effect it could have on how we engage with the universe. For instance, Polaris has served as the focal point for numerous stories from cultures and myths across the world. If the star were to vanish from view or dramatically change, it would change the way different communities use the night sky. Those who once regarded it as a representation of hope and constancy would experience an emotional void. This eventual shift in the North Star's position could also inspire further exploration into the complex relationship between gravity, stellar motion, and the structure of the universe.